My name is Elijah Wiegmann. I'm the founder of Base Design. Previous to that, I was the design director at Four Moms. So I had worked there for a number of years developing high-tech, innovative baby products. And then my life before that, even where I went to kind of straight out of school and learned how to make stuff, is Michael Graves Design Group. So we made a ton of products for places like Target, mops, brooms, buckets, toasters. I mean, it gave us a real understanding of how to make things. So this talk focuses on how to make stuff, incorporating design thinking. So a lot of the times when you're into an idea or you're developing something, it's a very nebulous process. There's no real roadmap. Design thinking is a way to take uncertainty and to focus it, right? So you have a lot of ideas spinning around, a lot of research, maybe some experiments. What you want to do is put that through a process so that you're coming out with something that is replicatable, testable, that you can focus that effort, right? Designers are the people that like ambiguity, right? Like we like what ifs, we like post-it notes up on the wall, we like ideas. We're always, unfortunately, the ones who are adding to stuff in a project, right? We ask like why is it that way? We're like the sensitive artists, right? And sensitive in terms of if a handle's not quite right, that sticks with us, or if something feels a little heavy or it's hard to use or confusing, like we're sensitive. For instance, that blue's not blue enough, and I don't like this. Like this thing is awful. I can't stand it. We're always asking, does it have to be like that? What that's good for is we're also the canaries. So a lot of the time as entrepreneurs, when you have an idea or your service or your UI that you've built out, you might be a little bit close to it. You might be a little bit more in love with it, right? So this is the part where you as an entrepreneur get sensitive, and designers tend to ask the questions like, have you actually tested this? Are our costs in line? Can we actually make this for what we need to make it for? What's it made out of? Who can help us connect this? So we're always kind of like the little chirping bird in the corner of the process if designers are doing it right. So design thinking is a pretty uniform process when you actually map it out. Number one is empathize. You want to develop a deep understanding of what you're trying to solve. You want to do research. You want to walk in those shoes. Then number two, you want to define that. You want to clearly articulate like what you're trying to solve, the actual problem. After that, step three is to ideate on that, to brainstorm solutions, to cast a wide net, a bunch of what ifs. And then you want to prototype that, and then you want to test it. So the first stage of this is the question hypothesis, right? So, we've got the chalkboard here, what if? So you want to ask yourself the question of, why is it like this? Why is my banking app so confusing to log into? Why is this chair so heavy? Why doesn't this fold smaller, right? You want to come up with a bunch of reasons why that is, and then that lets you start jumping into testing it. The design process is a cyclical process. Like, many of you might be familiar with the agile method, where you do a round of testing. This is the famous OXO potato peeler, but you see the iterations of just kind of testing it quickly. It does not have to be beautiful. It does not have to be fully baked. You want to get to the testing as quickly as possible. You want to iterate on those, right? So all of the sketching, these can be physical sketching, like we're showing here with a lamp idea. These can be iterating UI designs. These can be flow charts. this methodology is mainly about the process, right? So you want to be iterating through as many possible solutions early on, because that saves you time, money, and effort in the back end. The more you iterate up front, the more then you can start distilling and focusing in on what you need to. You cast a wide net and keep cycling it down. So how do you question the first part? Like, how do you build empathy? How do you get inside the head? There's some good exercises, particularly for teams of people. You know, if you have the marketing person, the salesperson, the engineering person, the CEO, the designer, if you have all of them in a room, designers kind of have this little card deck of exercises that are good to play through, right? So these are just a range of things. At the bottom, there's a website, and all of this is we can share later. But you've got storyboarding, where you can actually write through the process. You've got connections. Scamper, I'd have to remember what that is. The point is things like connections, right? What if you take a lamp, a banana, you get a banana lamp, right? But this is ways to see connections that may not have existed, right? Like the famous one now that's 20 years old is the iPhone, when Steve's up there saying it's a digital communication device, a web browser, and a MP3 player, right? Combining things. So one of the ways you can kind of question and test your hypothesis quickly is making connections. What if we made this chair out of carbon fiber? What if the chair was made out of cast iron? What if the chair was made out of bamboo? I really like that. Makes me think of this is an additive process. This is almost like improv in a way. I'm not a fan of improv, but that makes me think of is adding on to what someone else's idea is, right? So let's say somebody comes into the process and says, boy, I wish this thing had, a little handle on the backside. Adding on to that, being additive in the beginning is a good process, because you start noticing small connections in the design process you might not notice. And then you're whittling that down. So this is a way to build that tree of potential ideas, concepts. You can get a lot more coverage of exploring the problem and the question that way. Wishing. A lot of the times in the design process or development process, wishing is a bad thing. You're just hoping that it magically gets lighter or cheaper. But in the beginning of this process, this is where you see your opportunities. This is where you can find those little niches. If you're working on a project and you just keep hitting a wall in terms of, boy, I wish it would be so much easier if I didn't have to worry about the material breaking or the weight of this thing or the complexity of the instructions. All of those are key areas that you should highlight and then start developing around, because those are your areas of opportunity. You want to test quickly? I think I've said it a couple times in this, and I'll continue to say it. Those ideas then that you're putting onto the wall, those Post-its, you want to be looking through them. You want to be cross-referencing them. You want to be canceling out a bunch. You want to throw them away, right? You want to refine your wall full of Post-it note ideas as quickly as you can. You want to dump out whatever sinks to the bottom. And then you want to start iterating, which is then tuning in on the top, 3 to 5 concepts within that. That's the point where you're making small little adjustments, changes, tweaks. It's the cyclical process where you'll be taking that concept and you say, okay, for this water bottle, it's hands-free. And what if we did the button here? What if we did the button here? What if it twisted? What if it flipped? This is the iterating stage where you're refining that process, right? you're not going wider afield at this point in it. Focus. This is in gym class. If you're not very good at sports, you're always the last one picked, but you need to pick your ideas is the point. You're looking at your whole board of Post-its, of where you can go, all of the different opportunities and constraints that you're working with. In this stage, you really need to start picking your top three. You need to pick the best players, the most options, what you think has the most potential. From that, so all of that is the design process, right? The next stage of this that people ask about is how are you quantifying this? How are you judging what's good and what's bad? Or if you have a wall full of Post-it notes or concepts or ideas, directions you can go, the only way to make an educated choice about things is knowing the constraints. One of my favorite designers, Charles and Ray Eames, mid-century modern furniture designers, just kings of design thinking. Charles said this: one of the most effective abilities of a designer is to recognize the constraints as early as possible, right? So a lot of the times, I think particularly designers get a bad rap for being the dreamers, being the people that want to push the envelope, that build up to that edge. Knowing the constraints, but then being able to work into those constraints is one of the most powerful things. Constraints of price, size, strength, balance, surface, time. Being happy to work within those is the kind of magic sauce so that you're not that annoying designer always asking the questions, but rather working within a framework for the entire group. The other really important thing that I don't think it's mentioned enough in the design process is if you understand the constraints, that doesn't necessarily mean everybody on your team understands the constraints. So you could be working, let's say the engineering team is working on making this as thin and as strong as they possibly can. The logistics and sales team actually want it to be the cheapest and most manufacturable it can, right? Those two things are at odds. So knowing the constraints and then having the group align together on the top constraints, what's the most important. And this gets into an argument, right? Like a lot of the time, each department has their own constraints that are most important to them. But getting all of them up there on the board, being able to look at all of them all at once, and all come to a consensus that if we were to hit the top three constraints that we're working towards, is it weight, complexity, and cost? Is it cost, logistics, like shipping easily, and premium materials? What are those constraints? To then prototype those ideas, once you know all of those constraints and you've agreed on your guidebook of what you're working towards, you want to start organizing your prototypes. So when I talk about a prototype, it can be anything, but it's really about the design thinking behind those Post-it notes. The concepts that you're starting out early stage. You want to start organizing all of those into families or categories, what it's solving for. Very rarely does an idea just pop into the world as a fully formed, well thought out thing, right? Usually those Post-it notes are addressing one aspect of it, right? So if you've got concepts for let's say a UI, usually there's a stage where it's a concept around, say, the checkout experience compared to the putting your information in experience. So you want to organize those and start filtering them so that you can then organize and test. Prototyping is like this. Remember the slide earlier where you had that makes me think of? That's that slide on the left there where it says design, branching, exploration. It's like a tree, right? There's all these different ideas. Some of them are dead ends. Some of them are big branches that are really important to the prototype or the product. Some are little branches. At some point, you have that red line though, and you see that red line that goes vertically through it. That's where you start making those choices and focusing. And then that becomes an iterative experience. So then it pops over to the right side where prototyping is incremental and iterative. So you start this wide spiral of ideas and it starts tightening and tightening. The tighter you can get that little spiral with your product or your idea, the better you're going to be. One of the big things with prototyping is who is the audience? What is this prototype for, right? So I think typically people think in that upper right corner, right? So it's high fidelity and a very complete product. That's for user testing, right? That's handing somebody the stroller and saying, hey, mom, put your kiddo in this, walk 20 miles, see what you think, what breaks, what do you like, what don't you like? That's a completely different thing than a bench prototype of the hub generator and the wheel to make sure that it works, right? So a partial concept that's low fidelity. That's a bench model that you can build. I think a lot of the time, particularly early stage innovative ideas get consumed with trying to achieve what's in the upper right corner rather than thinking about, is it easy enough to just be testing the logic? Or sometimes a client comes to us wanting to figure out all of the details and all of the stuff and test it and make sure that we've got a complete thing. And as we get to the bottom of it, they really just need to sell the idea either to investors, to their board of directors, even to their engineering department. So you can do a partial model that's higher fidelity, you know, so questioning which audience you're addressing with your prototype is really, really helpful. This stage in prototyping isn't about how to make it, right? This is like a super complex mold with like 5 different pools on it. And I can't even imagine the part that pops out of this thing. This is not that stage. The stage here is about making ideas quickly, whittling them down, tightening it up, testing it, breaking it, seeing what's working, what's not. If you start putting limitations on how to make it, or what is it made out of, or how do we send this out to all of our users, that's going to start impeding the process. This is just a little like freebie. It came out a while ago in 2009, but this is the best overview of prototyping ever. So it's got this kind of systematic approach where you've got the concept, development, and embodiment on the left side there. And then it's aligned to the level of fidelity, right? So an idea sketch is literally that, napkin sketching. Once you start going a little bit further, you don't have to be an artist, right? You don't have to be able to do a gorgeous napkin sketch. Number 5, a coded sketch. That's just you figuring out, this pulley goes over there, this pulley goes over there. A memory sketch, you know, that's like UI development right there. It doesn't have to be pretty, but it's putting the thoughts down on paper. You get more of the traditional design sketching. It starts tightening up. You can see storyboarding there, layout renderings, presentation renderings. That's another example of like selling the idea to clients, investors, any of that, as opposed to some of the things where you're doing detailed drawings for either mold analysis or technical diagrams. But this little document is just wonderfully inspirational when you're developing a product to be questioning if you're doing the right level of prototype, of model. You know, most people are trying to skip to this like number 29 final hardware prototype, which is really expensive, really time consuming, and hard to do without having done the earlier stage stuff. So look that up. Drawing is free. Like I mentioned earlier, you can do mind maps, you can do flow charts, you can do, you know, lists of documents. But the physical act of putting something out of your mind onto paper or onto a whiteboard is scientifically proven that it's just easier to get the idea out there, to spread the word, like to get everybody aligned to what you're working on. Seeing it in a snapshot is literally worth 1,000 words. So a lot of the time, innovators, entrepreneurs are kind of stuck in their own head and they have this perfect idea. Just get it out there. Just put it out quickly. Physical prototypes. This is the fun stuff. Build it, craft time. Some of the easiest stuff with physical product is off the shelf, right? Like go to Home Depot and start hacking stuff. Glue some 2x4s together, go to the nuts and bolts, start bolting it together with stuff that's not off of a 3D printer, stuff that's not custom made, right? Like just see if it works. The best thing that design school teaches you, at first you're trying to invent everything that you're making, right? Like if you're making a drill, you're starting with just foam and starting to hack stuff up, right? Buy a drill and take it apart, right? Cut the back off of it and glue your part to the back of the already existing drill. Like, don't reinvent the wheel. If you're working on a chair, do you have a chair that you can hack and put some arms on to test your theory about, the fold-away arms? Just buy it and hack it. Cardboard's great. I mean, this goes without saying, but this is a really crappy model that somebody did, but I'll bet it got a lot of ideas out there, and the process of making it really probably helped. Sculpey clay Play-Doh. This is really fun. Again, not letting the resolution get in your way. So a lot of people will be worried that, well, I can't sculpt something that's that clean, or that, that it is exactly that. Well, just grab the Play-Doh and squish it into like a rough hand shape if we're working on handles, right? Like it's all about the exploration of it rather than the final execution of it. Still to this day, designing in clay, they still are carving, because there's something, again, getting it out of the cerebral, out of the cloud in our heads into a physical form lets everybody on that team walk around that car and understand how the headlight's going to run in the crease line of this. Foam's great. This is a typical industrial design material. You get a lot more resolution. As these go up, they get more and more complex, right? So this is that kind of middle stage where you'd be doing specific testing about handle proportion or shape. The thing that we have gotten even more into with base design and in general is soft goods. You don't realize when you look around the world how much is actually made of fabric or materials sewn together. You can use paper, tape to get a cardboard sample like this, but the magic of soft goods is you don't need to be an expert seamstress or prototyper to do this. Like, you can hack together functional prototypes that actually work so quickly in soft goods that it kind of laps everything, right? The next level, this is where you start engaging with either an industrial designer or a firm. CAD models, right? I think in today's day and age, people jump into CAD really quickly and they miss a lot of the exploration that goes along with sketching, being in the shop, cutting and using, Play-Doh and foam to hack something together. CAD models are wonderful, but they take a lot of expertise. If you don't know how to do it, they take a lot of complexity. Sometimes things break in the software that are limiting you, that if you were just cutting it with, a bandsaw, it wouldn't be that. Photorealistic renderings. This is, again, towards that sales side of the prototype scale, where you're agreeing on colors, materials, textures. This is a good way to be looking at where the branding goes on the product. This is a 3D scanner we developed with Carta, and early stage, we were literally just carrying around a tablet like stapled to the LiDAR. And then as this project evolved, like, by this point, this was for some of their rounds of investment to show potential investors. Only then were we jumping into 3D printing, right? So it's great resolution, but the later in the process you can be with this, I think the wider your ideas will be and the less limited. 3D printing is amazing, and we're printing every day at base, but you have to know why you're printing. A lot of the time you get really excited and you just want to see that machine, that part out of the machine, and you get ahead of yourself. So we had 3D printed this, and then it was testing where the button location was. So this actual panel was magnetized in and out, and you could, one concept had it pulled over another, 20 millimeters. One was up a little bit further. So you want to think about what you're testing and how to set that up. This is the painted appearance model of that. So once we got all the way to that level, we were 3D printing, putting in the real parts, trying to really get things in front of you. Something that's really cool for services, for digital products, for UI, any of that, what I call invisible prototyping. There's a bunch of different exercises you can do. Acting it out is a great one. So let's say we're developing, a sign-in kiosk, for people. Walking through that process and actually physically walking over to it and hitting the button and, understanding whether it's too tall or, oh, it's weird. You reached into your back pocket for your wallet, and wouldn't it be better if we had a small table there that you could set things so that you had your hands free? Like, you discover little tidbits that make your design that much better when you're acting it out. 7-14-28. Any of the software engineers will know this exercise. Make a peanut butter sandwich in 7 steps, right? Take the bread out of the bag, put the peanut butter on the bread, put the jelly on, close it. But then do it in 14 steps. Then do it in 28 steps, right? By the time you're doing 28 steps with whatever your process is, you are seeing the tiny little niche opportunities of, oh, that's right. It is a pain in the butt to get the bread tag off of the bag of bread, because you're seeing these little micro transactions of users, right? It gives you an insight into what you might take for granted, but your users might be getting hung up on. Just a really good way to dig deeper into the process. Scale is really important. If you're designing something, they design entire buildings at scale, 1/100th of what it is. The other way is 1-to-1. What I learned really early on in my design career was, when you're designing a spatula, you shouldn't be drawing the spatula twice the size. You shouldn't model it half the scale. You should design it spatula sized, 1-to-1, right? It sounds intuitive, but a lot of people confuse model making with prototyping. Being able to sit in the chair that you're designing is first and foremost the most important thing, right? Like, when you design a car interior, you don't design it half scale or double scale. You want it human sized. Everybody here is a human. We're all using the same stuff. There's a pretty wide range of ergonomics that we've all agreed we're going to work within. Doors are a certain size, right? With scale, you can do fun things like this. Going 1-to-1 is a shortcut when you're hung up on process. And what I mean by that is, if you're designing a kitchen layout and you're trying to draw it out, or you're in CAD and you're wondering, where should the kitchen sink be, or where are the cabinets, just starting to put tape on the walls and living in that area will really help understand and test whether those cabinets are too high, or whether your flow through the prep station to the kitchen to the oven, is smooth or whether you've got steps in there, right? These are these little cheats that you don't need to design the actual kitchen and dive in and have it all figured out. But start putting tape on the walls, and before you know it, you're going to have your kind of framework set up. Same deal, right? If you're deciding what the silhouette or profile, the crease lines of a car are, then just focus on the crease lines of the car. You don't need to build an entire clay model to move that line down another 10 millimeters or 20 millimeters up. Human scale. I mentioned this earlier. We are all roughly the same size within a gamut, right? There's no 20 feet tall people. One of the best things is just putting this on people, putting it with people, handing it to them. We were testing battery storage solutions for this, and you can see just how ridiculous that would be if you were carrying around, what engineering had proposed as the giant battery that we had to use. Get it in people's hands, right? It's not just about sense of scale. People know how to break stuff. They're really, really good at it, right? Like, hand them an IKEA chair that's unassembled, and they'll all figure out different ways to assemble this thing with very clear directions, right? You fall in love with your idea. You say, oh, it's so easy. You just twist it, set it down, and it does that. Well, hand it to one of these people and they'll have it upside down and backwards before you know it. So you need to kind of get it out there and not be precious about letting people break it. Have those hard conversations, right? And be honest with yourself and your team. You're already putting your baby out there, your idea, your new product, your service, whatever it is, you're going to be a little sensitive, right? Having those really honest conversations and being okay with some lunkhead messing it up and not going, he didn't understand because he's a lunkhead. Be honest with it and say, what could we do better that's going to fix that problem, right? How can we fix that? Along with that, once the people have broken it and you've kind of developed through that round of things, talk to a vendor. These people know how to make stuff. A lot of the times, particularly products, but it can be anything, services, digital, any of that. It's developed in a research lab or in the engineering bay or at the startup. It's not like making it is like this last step that you're like, and then we'll just toss it over to the factory and they make it. That's pure lunacy to think that you're going to know what wall thickness the bottle should be molded at compared to the place that makes bottles day in and day out for the last 60 years, right? So including vendors and manufacturers in the front end of this process is a lot better. With all of this prototyping stuff, there's only like 2 golden rules. I hope it's clear that you cast a wide net with all this, right? So there's no set Bible, but the 2 absolutes is there's no set number of prototypes, but make as many as you possibly can, right? The answer is more than one. And number 2 is each prototype is going to teach you something. Just the act of you testing out that post-it on the wall or acting it out or making a clay model, it's going to teach you something, and it's usually going to make your design better. This is my little left turn. This is just as I say, there's no like Bible to this process of prototyping. Here's my guide to making things. This is like my little internal filter mechanism of when we're working on stuff, what I filter it through. These are little surface things now, right? I was talking about process earlier. These are actual kind of tips and tricks. Alignment, line things up. This Lincoln, I hate. It's awful. And the reasons are all of those body panels, the little seams that you see that come up into the tail light, that come up, you see the jog in the trunk. It breaks that crease line right through there. look at the lower area of the doors. There's 12 different horizontal lines going across this where it's a crease, then it's the door edge, then it's another body crease. Line things up, make it cleaner, right? If you see two lines, try to line them up so that they're lined up. Humans love when things align, when they fit together, when they look like they're meant to be, right? It takes off cognitive load. When you see this car going down the road, your eyes looking at a lot of stuff, right? When you see this coffee maker, you feel calmer. You feel like this is approachable. You know what to do. And it's all about lining up all of the different proportions. Beauty gaps. Cars do this a lot, but products do it. Injection molding does it a lot. Beauty gaps are how parts fit together because we don't live in magical CAD land where things can just all be one piece. Sometimes you have to connect things. Planning for that gap, the way two plastic shells come together to meet, to snap together, actually affords you a good opportunity, right? This is a really neat example of that where the bottom shell and the top shell of this casing, instead of trying to get a perfect fit up to it, which is never going to happen and it's going to waver or walk across the mold, they accentuated it. And then that gave them a great place to be putting status lights and, icons and LEDs. We did the same thing here where lining up that beauty gap rail, we were having a lot of problems with the way it all fitted up. So we actually offset that and made an actual track into that product. A lot cleaner, a lot easier. The mold factory was super, super happy about, wow, we can hit any tolerance and these still just clip together. Pick one thing to celebrate, right? This is just really nice red color with the aluminum connection. I think this is like an old Bluetooth speaker at this point. But the rest of it is just a black box with holes. If you're celebrating the one thing, that gives your users something iconic to latch on to, something that when they leave the experience, they might not even know why they liked it, but they're like, but it had a really nice handle. Like boy, I love this computer because every time I lift the lid, it's got this really nice click feel. Pick one thing to celebrate and dial that in. Try combining pieces. I think this is a pretty elegant way to combine the back window glass into the actual tailgate, right? So that black portal there, it all opens up. By combining the traditional tailgate with the glass, all of a sudden you have like a design feature that's kind of eye-catching, and it's the things that people notice that set it apart from what everything else is. When you start combining materials or merging two pieces together that may not have been merged before, all of a sudden it's kind of refreshing and it catches people's attention. Using multiple materials, again, this goes to like the soft goods thing. If you think about the chairs you're sitting in, there's 12 different materials in that one chair, right? You'd assume that it's a chair, it's aluminum, I guess. But you've got upholstered seats, you've got a stretch mesh. Using multiple materials gives you places where you can be signifying that you want high touch. You want people to focus on this area. Use multiple materials and that'll connect in a nice way. Use soft goods. I'm the biggest champion of these soft goods are basically free. Like you could prototype that yourself. A factory can churn out 1 billion of those. You can change that tomorrow in the physical product and just ship it with a new liner, a new case, and you haven't molded the plastic case. You're not $100,000 into tooling cost. You literally just pick a darker gray felt, right? So think about using soft goods in places where it might not be used. Play with scale. This is really one of the secrets of how places like Apple or some of the higher design places do things. When you look at the joint of the stroller on the left, That's the thing that they bolted together, and they were like, all right, the tube has to be 25 millimeters. That means that the joint then has to be 30 millimeters. Here's the pin. Whereas this stroller company started playing with scale. They blew that joint up, in terms of where it's fitting. Instead of the one pivot point, they moved it out, and that joint's like 60 to 80 millimeters in real life. It's a big rotational joint. But because of that, it's just so satisfying. Seeing that hinge is a design element. It feels good. It functions really well. So play with scale. If you've got a handle, try it really, really small. Try it really, really big. Yeah, mess with scale, and all of a sudden you start discovering cool little things. So this is just to leave you with the process one last time. Everything in this was some stage of this process. Develop a deep understanding, define the problem, agree on the constraints with your team, ideate on those constraints, then start prototyping, build your test stuff, and then test it, break it, get it in front of vendors, figure out that it costs too much, go back to prototyping, keep going back through this process. If you're going through this, you're applying design thinking to basically any idea, and you're going to be getting tighter and tighter final outcomes from that. And that's all I got.